Dear students, welcome back. This is going to be our last lesson on enlargement. In this lesson, we're going to see how to perform an enlargement by construction, and also we're going to see the relationship between enlarged, that is similar shapes, and their perimeters and their areas. So, our topic is still transformations, and that's enlargements. Our objective for today, we're going to learn how to construct enlargements and the relationship between enlarged shapes and perimeter and area. So, I'm going to start by trying to construct an enlargement. Okay, so sometimes you're going to have an enlargement where you don't have a grid. Meaning, for example, you're going to have a shape. I'm going to draw a triangle. And we need to enlarge this triangle from this point, P. So this is P, this is triangle ABC. Okay, our instruction is going to be to enlarge triangle ABC by a scale factor. I'm going to use 3 from the point P, and we don't have any further instructions. So that's point P. I'm going to fix a little bit that. Okay, and we need to enlarge. So we don't have a grid, so we're not going to count squares. So what we are going to do, so take a ruler, and using your ruler, place your ruler on the point and pass your ruler through each vertex. Alright, through each vertex, and draw 3 lines. Okay, 3 dotted lines or 3 very faint lines. I'm going to draw 3 faint lines. In fact, I'm going to use, because it will be more accurate for me, I'm going to use my designs, my shapes, and I'm going to draw 3 faint lines. This is the first one passing through B. I have another one passing through A. They have to be long lines. And I have another one passing through C. Okay, now, what am I going to do? We have to construct our enlargement. Scale factor 3. So we're going to take our compass, place it on point P, and arrive to point C. There I have measured the distance from P to C. Now, the distance must be enlarged by a scale factor of 3. So what I'm going to do? That's 1. I keep my radius. That's 2. Keep your radius. That's 3. And there I have my new point C. So now this is the new point C. I'm going to do the same for the other 2. So I'm going to place that on P. And I need to arrive to A. Let's see, that's almost A. So this is A. Alright, so that's 1. That's 1. Moving now on A. This is 2. Moving on my new point. That is 3. Alright, so now this is my new point A. So I have the new point A, the new point C. I need B. So now I move that to B. Let's see, it must be a little slightly larger. Okay, that's correct. So that's distance PB. Moving that. So 1, 2. Last one. 3. So that is my new point B. So I've got A, I've got B, I've got C. What I've got to do now is to draw the new triangle ABC. And ABC is enlargement scale factor 3 from my original shape. So that's how to construct an enlargement when you don't have a grid. Okay, you can also do this when you have a grid, but when you have a grid, it's more accurate to do it on the grid than this. Okay, you have to be very careful. Your compass must be a good compass. It must have a sharp point, both for the compass and for the pencil. Okay, and you must be very clear in your constructions. Okay, so this is the construction. Now, if you remember in our latest lessons, we have been doing constructions, enlargements. Let's see one of these enlargements. So I'm going to perform an enlargement, this time on a grid. So let's say that we have the following grid, we have the following triangle. Okay, and we are going to enlarge this triangle. We're going to call it triangle A. Alright, enlarge triangle A by a scale factor of 3 from the point 0, 0 from the origin. Let's remind ourselves a little bit. Triangle A has coordinates, vertex coordinates. I'm going to call them PQR. P is the coordinate 2, 1. Q is the coordinate 5, 1, and R is the coordinate 3, 3. I need to enlarge from the origin, so I need to multiply the scale by the scale factor of enlargement. Multiplying each one by 3, I will get 6, 3. I will get 15, 3, and I will get 9, 9. I go and plot those. So it is 6, 3. First one. I've got 15, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 3. Second one. So this is my new P, this is my new Q, and R 9, 9, 6, 7, 8, 9, 1, 2, 3, 6, 7, 8, 9. So that is the new point R. So I've got now my enlarged triangle. I'm going to draw the triangle. Okay, and that's my triangle, my enlarged triangle. So triangle, this triangle is enlarged by a scale factor of 3. Now let's see something about, for example, their areas. Okay, so we know that the ratio of sides, is 1:3 because we enlarged by a scale factor of 3. Now, if I had to find the area of triangle A, I'm going to try to call them A and B, okay? So, the area of triangle A is base times height on 2 because that's a triangle. The base of triangle A is 3. The height is 2. 3 times 2 divided by 2. That is 3 square units. That is 3 square units. The area of triangle B is also base times height on 2. And that's equivalent to base is 9, height is 6, divided by 2. 9 times 6 on 2 is 27 square units. So if I had to talk about the ratio of the area, the ratio of area is 3:27, which can be simplified to 1:9 because I could divide by 3 because 3 is a common factor, which I could also write as 1:3 squared, because 1 squared is 9 and 3 squared is 9. And note that this 1:3 is the same 1:3. So that is the area. We can also find the relationship between the perimeter of that shape, all right, between the perimeter. So let's measure the sides. Okay, we could also use Pythagoras theorem, but it's easier to measure here. So I have PQ 2.4 centimeters. PQ is 2.4 centimeters. This side here is 7.2 centimeters. It makes sense because that is 3 times as much. And 3 times 2.4 is 7.2. I'm going to measure PQ now. PR, sorry. PR is 1.8 centimeters. If I measure PR, the new PR, that's 5.4 centimeters. It also makes sense because it is 3 times as much. I'm now going to measure RQ. RQ is 2.25, 2.3 centimeters. If I measure the new RQ, that's 6.9 centimeters. Also 3 times as much. So if I now find the perimeter of A, the perimeter of A is 2.4 plus 1.8 plus 2.3, which gives a total of 6.5 centimeters. Let me check again. Okay, 6.5 centimeters. We can find the perimeter of B. Perimeter of B, which is 5.4 plus 7.2 plus 6.9, which is equal to 19.5 centimeters. So, if I had to write the relationship between the ratio of the perimeter, so ratio of perimeter of triangle A to triangle B is 6.5 is to 19.5, which can be simplified, divide by 6.5, and it will become 1:3. So as you're noticing, that 1:3 is always there, The ratio of sides is the same as the ratio of the perimeter. Remember that has been enlarged by a scale factor of 3. Remember also that when enlarging a shape, I don't change the angles, okay? So the angles of PQ and R and P dash Q dash R dash are the same angles, okay? Only the sides have grown bigger. So what's very important from here? From here I can get the following information. This information here, which I have, all right, highlighted here, that is a very piece of important information. I'm going to write it again in a new page and explain it a little bit more. So what we have found here? We have found that the ratio of sides is equal to the ratio of the perimeter. So if one triangle is enlarged 4 times from the other, the larger triangle has a perimeter which is 4 times the perimeter of the smaller triangle. And also that the ratio of area of two enlarged, therefore similar shapes, is equal to the ratio of sides to the power of 2. Okay, to the power of 2. What does this mean? This means, for example, if I am making a cake and I am using around tin, let's say this tin has a radius of 4 centimeters and this tin has a radius of 8 centimeters. Okay, so if I compare those two tins, I know that the ratio of length or of sides is 4:8, which is 1:2, meaning that the larger tin has a perimeter or circumference which is twice as large as that of the smaller tin. Now, what is the ratio of area if I compare the areas of the two shapes? The ratio of area is going to be the ratio of sides squared. So it's going to be 1:2 squared, which gives a value of 1:4. What does this mean? This means that the area of the larger circle, of the larger tin, is 4 times the area of the smaller tin. Meaning, for example, if I have a recipe and it's a cake recipe and I need 3 eggs for the smaller tin, to bake the same cake in the larger tin, keeping in mind that it's going to be the same height, okay, we're not going to change the volume, the height. If I need the same height of cake in the larger tin, since it has an area which is 4 times as big, the number of eggs needed for this tin is 12 eggs, not 6, okay? Because you might say, look, the one is 4, the other is 8, so twice as much. So if I need 3 eggs for the smaller one, I need 6 eggs for the larger one. That's a mistake, that's wrong, because we're comparing the areas, and the ratio of the area is the square of the ratio of the sides. So this is very important. This is what you need to keep in mind, because you might even need it in everyday life, especially those of you who may have hospitality or home economics as one of their main subjects. So that's all for this topic. That's all for today. Have a nice day.